Hello fellow nerds, welcome back to our YouTube channel. So in this video we're going to look at functions, and to be specific we're going to look at how to find the domain of a function. So what do we understand by the domain of a function? So the domain of a function is just the values of x that will make a function to be defined. The values of x that will make a function to be defined. So we'll do the following examples. Example 1. So saying find the domain of the following functions. So the first function we have is f of x is equals to x minus 9. So what are the values of x that will make this function to be defined? So we'll find that all the real numbers will make this function to be defined. So we say domain of f of x, or domain of f, it's okay. Domain of f is equals to real numbers, or you can say x as a member of real numbers, or you just write real numbers, or if you want you can write it like this. You can write it negative infinity to infinity. Okay, we'll move on. Second function. So we have f of x equals to x plus 9 over 5. So what are the values of x that will make this function to be defined? So we are talking about all the real numbers will make this function to be defined, because even if we put a negative value there, the function will be defined. If we put 0, the function will be defined. Therefore, domain of f is equals to real numbers. Move on to the third one. So f of x, okay, third one is f of x equals to x minus 3 over 2. So same goes with this one. All the real numbers will make this function to be defined, because it doesn't matter the number, the value you're going to put there, as long as it's a real number, the function is going to be defined. So the domain f is equals to real numbers. The fourth one. What is our fourth function? So our fourth function is f of x equals to square root of x minus 1. So this one, we know that a square root to be defined, we are supposed to have we are not supposed to have negative values under the square root. So the square root of a negative value will give you a complex number. So what are the values of x that will make this function to be defined? So what we do here is say x minus 1 should be greater or equal to 0. Should be greater or equal to 0. And our x, you saw for x now, so our x will be greater or equal to 1. So that will be our domain. So meaning, you know that our x should be greater or equal to 1. So you say domain f is equals to x, the member of real numbers, such that x should be greater or equal to 1. Or you say 1 comma infinity. Like that, you've written the domain for that one. We'll move on to the fifth example, which is f of x equals to cube root of x minus 1. So what's the cube root of x minus 1? So under the cube root, it doesn't matter whether it's a negative value, a positive value, it will definitely give you the answer. So for example, the cube root of 8 is negative 2. The cube root of negative 8 is negative 2. The cube root of 8 is 2. So it doesn't matter whether you put a negative value or a positive value, it will give you the answer. So for this one, we'll say all real numbers, because any real number that you place there on x, it will be defined. So domain of f is equals to real numbers. Okay, we move on. Example 6. So example 6 is 1 over x minus 1 for x should be greater than that. So example 6 should be f of x equals to 1 over x minus 1 for x should be greater than 1. So we know that for a function to be defined, we're not supposed to have 0 on the denominator. So if 0 is on the denominator, the function is undefined. So what we say, we'll say x minus 1 should not be equal to 0. Then you say x, you solve for x should not be equal to 1. So what do I mean by x should not be equal to 1? So x can be equal to any real number, but not 1. If we are showing on the real line, we can show it like this. So this is 1. So it can be like this to there. So meaning x can be any value but not 1. So if we were to show in interval notation, we can say negative infinity comma 1 union 1 comma infinity, like that. But note that there is a condition for x should be greater than 1. So this will limit us. They are saying x should just be greater than 1. So we only have from here going to there. So our domain for f for that function is x should be a member of real numbers such that x should be greater than 1. Or an interval notation, you can write it like this. So 1 comma infinity. So if you remember, this is set builder notation and this is interval notation. Alright, so for this video we are going to end here. We'll continue with the example in the next video. Please watch the next video for the follow-up questions are more complicated than the ones we are doing. So please don't end here and watch the next video. Thank you.